set an operating system of some kind, cleans it up, you know, from what was there before. I think it's perfect for amateur.
Yeah,
You
yeah.
know,
For things like Whisper running.
exactly.
It's pretty slick too. Looks good.
Everything
I always like to think that. That's what it is.
and I had it on for an hour and a half, and there still was an hour and a half or whatever in the battery, so I know it is a brand new battery. Nice.
That is nice. So has he got more?
Oh, yeah, no.
He'll set you up?
Yeah. Yes, if you go to eBay, you can buy one of these for 60, 70 bucks, not with a new battery, and he's cleaned it up. And I have trouble with the keyboard, so you just get in.
Really?
Yeah, you know, I had to go get it, and bring it back, you know. I don't think I could do that, but something you know, hand, I think this is a perfect size for hand. You know, maybe not for everyday use.
Yeah, for that kind of stuff, easy, yeah, definitely. I hate to have the table on here.
Oh, wait a minute, why don't we just put it on the table? Huh?
That's all the kids we have.
No, just lay it on the table.
When I left the door, I shut it down, but it would be less, so now I'm back. There used to be a couple of guys that get on the Brownsville, and they would talk up to the guys in the Brownsville. Yeah, it's kind of like Echo Link or IRL key that you can break up other rooms and you can go here, there, and everywhere. Really good for them.
What frequency is it on?
443.950.
Something I heard that frequency is on.
I'd like to say good morning and welcome everybody. Very good turnout here this morning. This is our fourth seminar, and Charter Radio Club sponsors it. Rick Bono is our presenter today, and he's going to tell us about portable end-fed half-wave antennas. The Charter Radio Club President Jerry, KB5TMC, and myself, we kind of ramrod these seminars because we'd like to get people together and we like to learn. So I'm going to turn it over to Rick, and let her rip.
Okay. Well, thank you, Cliff, and thank you all for coming to join us today. I really appreciate the turnout, and hopefully this will be an entertaining and an interesting session here today. So, my name is Rick Bono. I'm from here in Brownsville. My call sign is N05B. Some of you folks may have heard me on the Starlink repeater. One of the things I like playing with, especially, is antennas, and I've already given a presentation on a mag loop antenna that we did. I think that was our first presentation we did out here back in March or so this year, and also did one on a homemade bunny phone. So those presentations, by the way, are on our website. So if you guys want to take a look at what we did on there, they're certainly available for review. Today I wanted to talk about a portable end-fed half-wave antenna, and just about end-fed antennas in general. And you know, a lot of my motivation for playing with antennas is I like to work portable. I like to go out in the backyard and set up an antenna for the afternoon, and you know, try and work the bands on it, or be able to go out to something like the National Park Service. You know, is doing the national parks on the air this year. So you know, being able to go out to Palo Alto or setting one of these things up is something that interests me. So I'm always looking at a way to get an antenna up fairly easily, something that's effective, and being the lazy man I am, I like something that goes up pretty quick. So my goal here was to develop a portable end-fed half-wave antenna, something that's easy to deploy, something that has multi-band capability. I'm also looking for something that was resonant, so I didn't have to use an antenna tuner out in the field. And you know, power handling, I use an FT817, but I also have an amplifier for it. So when QRP just isn't getting it out, I'd like to be able to run at least 45 watts on it with the amplifier I've got. Ideally, I'd like it to run between 40 and 10 meter without having to go through too many gyrations for changing bands. I'd like to reference a lot of what I've got off this presentation today comes from Steve Yates, AA5TV. He's a fellow Texan here that has done a lot of work on both mag loops and infeds. Really good information there if you want to really get into depth on the subject. And I'd like to give him a lot of credit for some of the stuff in this presentation. So I'd like to start by talking a little bit about the dipole antenna. And we're all very familiar with the center fed antenna. The key of having the feed point in the center is that, as you can see from this graph, our voltage will be at a minimum, but the current is at a maximum. So if we remember Ohm's law, V equals IR, right? So V over I gives you the resistance or the impedance in this case. So in this case, we have a very small voltage with a very high current giving us a low impedance. So typically for a dipole, that's around 72 ohms, right? That's great for when you're trying to match up with a rig that's in a 50 ohm, looking for a 50 ohm load. But what happens as we move away from the center? As we move away from the center, the current starts coming down, the voltage starts going up. So by the time we get out here to the end, our current is really at a minimum and our voltage is now at a maximum. So if we look at that equation now, we'll see that we're starting to look at impedances that are in the 1800 to 5000 ohm range. So clearly that's going to be a problem matching to a 50 ohm, to a rig expecting a 50 ohm load. Given that, why would we want to use an infed wire antenna? The main thing is for a portable antenna, it does simplify the deployment. And meaning that, for example, in a vertical, all I have to do is send the end of the wire up to the top here. If this was for example, a vertical dipole, somewhere here at about 30 feet, I'm going to have to come out with my feed point, and I'm going to have to bring it out as perpendicular to the radiator as possible for a ways to ensure that that I get proper matching. So not only sending the end of the wire up, but also having to support the feed point about 30 feet off the ground starts getting a little onerous. With the infed antenna, all I have to do is send the end of the wire up, and my feed point's down here on the ground level where I can work with it fairly easy. The other nice thing is you can deploy these in ways that we're very familiar with in terms of different dipole configurations. You can use the inverted L, you can set it up as a sloper, half square, inverted V. The inverted V only needs to support the wire once again. It's not supporting the feed point or the feed line. The feed line will be down in here somewhere. I don't go into much about pattern and gain in this presentation because basically the pattern and gain is going to be the same as however you configure this antenna. It'll follow a dipole gain and pattern matching. So the real key here is that you have the feed point down in the ground here where it's at a convenient point to work with. You don't have to worry about supporting the feed lines up high in the air. By the way, we've got it set up just outside right now. We have it up on a 30-foot travel mast. The end of the wire is up about 30 feet. So there's actually two types of infed antennas, okay? There's a non-resident approach. And for the non-resident approach, what we have to do is first match the high impedance of the feed line with a 9-to-1 unun. Okay, so essentially it's a 9-to-1 transformer here. And that's to bring that high impedance of the feed point down to a level that's manageable for the rig. But it's not resident, so it's very important that the length of wire you use is not a length that is halfway multiple of any frequency you tend to use. Now, once you get onto the, let's see if this actually works. This website is kind of handy because it gives you links to avoid for different configurations. For example, here, if you want a 40, 30, 20, and 15 meter non-resident antenna, you need to avoid links that are in these red blocks. So, about 35 feet would be okay, 40 feet would be okay. 66 probably wouldn't be a good idea. And that's because those are multiples of the frequencies of these bands. The other thing is, this is multi-band, but you'll need a tuner, and you'll need a tuner on all bands, so that's something that's a requirement for this. I actually have, as my base home antenna, I have an InFed non-resident antenna that I've been using now since I got my ticket about 2 years ago. So it's actually worked out real well for me. I've got it, it's a 53-foot wire. It's strung up horizontally about 20 feet off the ground, and it's been working really well for me. So I do start getting the itch for a little gain every now and then, but you know, for just everyday use, it's been a really good antenna. But I do need to run it with a tuner. If you guys are interested in building one of these antennas, the definitive website is by the Emergency Amateur Radio Club in Honolulu. They used to actually sell this, but the instructions on building one of these things are really clear. I would definitely recommend you looking at this, winding the toroid for the matching, building the little matching box. Essentially, you have the wire coming in on one side, you have a ground coming in on the other, and then your feed line coming in there. So about as easy as it can get. Just hang on a wire anywhere between about 24 and 60 feet, and you're on the air.
How much are the toroids?
Depending on the size, right?
No, that one there.
How much is that toroid?
Yeah,
Tell you exactly.
approximately.
Let's see what it is. Bill of materials here. Let's see. It's a T130-2. I would say it's about $8, $8 to $10.
Okay.